This is the Fields Homework Booklet, question 26. The Hubble Space Telescope was launched in 1990 into a circular orbit near to the Earth. It travels around the Earth once every 97 minutes. You are asked to calculate the angular speed of the telescope and give an appropriate unit. You do have a choice here, so angular speed is angle swept out per unit time. You could have radians per second or degrees per second. So for one orbit, we have an angle of 2 pi radians, completed in 97 minutes, which I've converted to seconds, leading to an answer of 1.1 times 10 to the minus 3 radians per second. I've shown you the alternative for degrees here as well. Next, you're asked to calculate the radius of the orbit of the Hubble telescope. So many of the questions in gravitational fields rely on use of the equation for centripetal force and equating that to the expression for gravitational force. So this should be pretty familiar now. So putting down the two expressions, cancelling the masses of the satellite and dividing both sides by the radius of the orbit is changing this squared to a cubed. Then simplifying, we get the expression for the radius cubed is gm times the angular speed squared. So you've already worked out the angular speed, so that's very convenient to substitute here, and we have the value of the gravitational constant and the mass of Earth. Last step, make sure you don't forget it, is to take the cube root of your calculated answer for this. This leads to 6.99 times 10 to the 6 metres. The last part of the question gives you the mass of the telescope and asks you to find the magnitude of the centripetal force. Since we've been working with angular speed already in this question, it makes most sense to use F equals m omega squared r. There would be no sense really in using mv squared divided by r here. That would just lead to more work. So the mass of the telescope times omega squared times the radius of the orbit leads us to an answer of 8.97 times 10 to the 4 newtons. Worth noting that I have used an extra significant figure here from a previous part of the question. It is worth recording interim answers to an extra significant figure in case you need to use them later, as it improves the quality of your numbers further down the question. So that leads us to our final answer here. And just to note, you could also have used this expression for the gravitational force of attraction, and that would have given you the same answer.